here's the next one. We're looking at the next 10 questions and hopefully explaining them from first principle, from the very basics of where they come from, so we don't leave any stone unturned. And these are, again, I'll remind everyone, the essential skills that would be useful for getting to the grade 5 on a GCSE. And there are some skills, I think, which maybe go slightly beyond, but that's what we do. We shoot for the moon and end up amongst the stars. Let's get going. Why are x, y, and x squared y not like terms? Okay, so we're coming right in with the philosophy here. So a like term is a term that has the same terms in them. So we've got x, y, and x squared y. They're not like terms because they don't have the same balance of x and y. If I had x, y, that's x times y, and x squared y is x times y. Like terms are able to be added because they are the same thing. Okay, what's an additive inverse? Well, let's just take it a step at a time. An inverse would be like an opposite, something that would take it back or do the opposite of what happened. Additive is something that we would add to something. So the additive inverse that would take us back, well, if 12 is a force of magnitude 12, how would we inverse that? It would be, we would have to add something to it to inverse it. And I think the answer there is negative 12. So negative 12 would be the additive inverse that would bring it back to 0. Find the additive inverse of negative 7x. Okay, we just got the idea here that the additive inverse is something that would get rid of this term to 0. So up here, the 12, if we take away 12, it would go to 0. So that is the additive inverse. Here, what would make this go to 0? Well, it would be adding this, because currently it's already negative 7 lots of x. Common mistake might be to write plus 7. Well, that would be wrong, because actually we're talking about a certain amount of x. So we have to add 7 x's, not 7. So if I just leave it as that is, a positive, 7x is the additive inverse. That will take us back to 0. And what about the additive inverse of plus 3ab? What brings us to 0? Well, you'd have to take away that thing. That thing is positive. Take away that whole thing, it will give you nothing. Right, use the additive inverse to solve this. So, what does it mean to solve? Now we get to the more juicy math stuff. Well, to solve means you're going to find x. In this case, it's x, right? It's generally speaking the unknown. But it means to find x. And in equation terms, it can mean get x alone. In fact, I'm going to say make x the subject, because that's more technical than saying get it alone, but essentially that's what you're doing. If you want to make something the subject, you need to get rid of everything that's near it. So currently this plus 7 is right next to it and it's pain. The additive inverse is useful here because it helps us decide what will get rid of the thing we want to get rid of. We want to get rid of a plus 7 because if we can get rid of it, we will have a statement about x. Let's see what happens when we do that. I'm going to take away 7 from that side. Remember, it's like a balance, like a weighing scale. And so I have to take away 7 from that side too. And what is going to remain when I do that? Well, let's write it out in full. It would be x plus 7, take away 7. That's the new thing I'm doing right there. And on the right-hand side, it's 0, which is already there. And I'm going to take away 7 from it. Okay, what are we left with? What's the damage? Well, we have plus 7, take away 7, like we wanted, because we were trying to get rid of that 7. So it leaves us with just a little old x. Okay, on the right-hand side, 0 take away 7 is negative 7. Okay, there you go. Let's just take a quick look at that. That's what we were aiming for. And what does it mean? Well, if I put that back into the equation, I can see straight away it works. I got negative 7 plus 7, and yes, that does equal 0. So that's great. But what was like the whole statement of trying to get x on its own, like make it the subject, is because when you do that, you can read this a certain way. And the way you read it is literally x equals negative 7. You found it. So this method of doing the same thing to both sides, the balancing, is going to take you very far. It's really important. It's very methodical rather than brute force. And that's really what we want. All right, using the additive inverse here to solve this one. our aim is to solve this. So in part, we can use the additive inverse to begin. And to get rid of the things around the y, we're going to begin with getting rid of this -5. Now, if you're unsure about what you begin with these, it's going to be the opposite of bidmass. It's trying to write Bilbo Baggins by the looks of it. Bidmass. Now, if I'm going to be calculating, I will have to calculate in this order. But if I'm going to be solving, I'm going to be solving in the other order. And so that tells me that if I'm doing the rearrangement, addition and subtraction come before this multiplication here. Right, there's a good rule of thumb for you. Now, the additive inverse of -5 is +5. That's useful because it will get rid of this. It will take it to 0. But we have to do the same to this side. So I'm going to just jump a little bit here because I know that's going to go to 0. So what's left is 5y. And that's now got a 0 plus 5. That's got a 5 on the right. All right, the additive inverse is not going to help us here. Now, you'll notice that what we did up here was do the inverse operation. And like a -5 is +5. Well, what's the opposite of times 5? The opposite of times 5 is divide by 5. And remember, we've got to do the same to both sides, so let's divide by 5. Simplify this. Okay, so this is a case where what do you do because the brackets make it look more difficult? Well, you can kind of ignore them. And why do I say that? Well, because all of these are plus or negative or takeaways, right? So this is more to do with just saying this is a negative term. And you can see we've got the additive inverse there. So there's the 6x, and the additive inverse is -6x. And we're going to add those together. So here what we're learning is if we take the actual term and the additive inverse, and we add them together, we should get 0. So that's 0. I'm not going to write it because it's just gone. What's left in the collateral is 9. Okay, again here, this plus is going to distribute across, but thankfully plus has the effect of not changing what it interacts with. So we have a -3, which did no wrong, so we'll leave it. And it's going to be a +3a, and it's going to be a -4. Okay, so no harm there. Again, we've got the two additive inverses, so we're left with -4. All right, solve. This is going to require the additive inverse. And I always write what that is right underneath. It makes it easier to see right they're going to go. It's up to you, of course. We do to the left what we do to the right. It has to be balanced. And so what do we got? We've got x minus 9 plus 9. That's what we're doing on the left. I'm doing it out in full again because I think it's always good to remind ourselves that there's the thoroughness here to double check with. Now, if we had -9 plus 9, that's just going to go to 0. And what we're left with is this x that nothing happened to. -3 plus 9 is 6. I'm hoping that you're okay with your number lines. If you're not, you can feel free to draw a number line at any time in the exam. Like, do what you're going to be successful with. Okay, solve -2x. So this is a little bit more interesting. We don't often like, and this is something to write down, we don't often like the negative variable. Often easier to make it positive. So here's a little trick. Make it positive first. What's the additive inverse of 2x? It's plus 2x. So let's add 2x to both sides and see where we're left with. Okay, we're left with 8 on the left. This is going to go to 0, so that's it for the left-hand side of the equals. And the right-hand side, we've got 0 plus 2x, so we've got 2x. 2 times on the right, so I'm going to be dividing by 2 on both sides. So x equals 4. What do I like about this answer? Well, it shows you that you don't need to have x on the left. Like x equals 4 is also valid. It's fine. There's nothing wrong with it. But you don't have to. What's the reciprocal of 2/3? Well, the reciprocal is the thing that multiplies this so that it equals 1. And there is a trick to it, if you remember. You just flip it upside down. So 3/2. Awesome. And now, lastly, what is the additive inverse of x plus y? Well, there's a couple of ways of looking at this. As I've just done automatically, I've kind of put it in a bracket. So technically, I could write minus x plus y and then put a bracket around the outside, because it's the whole thing, right? What's the additive inverse of that? And this is perfectly fine. However, I can also see that it's what reduces this to 0. So I could also write, if I did this, it would work. Negative x, negative y. And if you notice, these two are the same thing. I've just distributed the negative into both, and then you would get this. So that is the additive inverse, the thing that gets your term to 0. Good to remember. All right, that's it for this time. Let's see you in the next one.